Miriam, everyone.
Hey.
So we were just having lunch, and you told me that you actually want to just change everything and do something entirely different, right?
Yeah, Calvin showed me the game he made for iOS.
Yes.
And I thought I'd just put that on the screen and we could just play for 45 minutes.
Sure, so it's similar to CSS.
And then
right?
take questions.
In some way.
Yeah.
Yeah, I mean, I'm not going to say no, but I might not approve of this.
All right.
Yes, but of course, when we're looking into the world of what's happening on the web, I mean, I was so impressed just to see how much and how incredible the speed of innovation in CSS was, and Miriam was very, very influential and contributing to it at scale. So I'm really, really grateful to that. And every time we have any conversations about CSS and how do we write CSS today, what should we do, should we not do, what would be the best way to architect CSS, to organize CSS, to manage complexity, especially in complex projects, well, I always stumble upon your wonderful work, and I'm always happy to hear some of the insights about what should or can or we are able to do today to make our CSS architecture better. So with this, please give a warm round of applause to Miriam SUZANNE.
Thank you. Always wonderful to be here. End of the day, how are you all feeling? Good, good. I know the question on all of your minds. Why doesn't my clicker work? That's one of the questions. Okay, this is the game we're playing. That's exciting. Yeah, there we go. Yeah, what the hell is a guaranteed invalid value? We'll get to it. Don't worry about it. How many of you have used variables in CSS? Yeah, most of you. They've been around for a while now, so that's good. How about variables in Sass or JavaScript? Yeah. These are going to be, OK, so here's a question. And I'm going to ask the same question in Sass and in JavaScript in case you're more familiar with one than the other. The answer is going to be the same. So the question is, we've got this variable myColor, mine. We set it to red, we set it to yellow, and then we set the background color to myColor, and then we set myColor to green and then to powder blue. What color is the background going to be? Here's the question in JavaScript. It's the same question. It gets the same answer. My color is red, and then it's yellow, and then we set the background to my color, and then it's green, and then it's blue. Do we know? Anyone want to? Yellow? That's right. Yeah. Imperative languages follow steps in order. So they read our code, and they say, OK, first we do this, and then we do this, and then we do this. So when they get to background color, at that point, my color is yellow, and so they set background color to yellow, and then we move on, and it's OK if the variable changes again. We're not using it again, so that can just happen, and it just goes away. Here's the same question in CSS. Red, yellow, then we set the background color, green, and powder blue, and I'm not going to let you answer that. CSS is a declarative language. So instead of a series of steps, what we have is a set of declarations. I've heard it described as a bucket of properties. We have like a selector rule, and we put a bucket of properties inside of that. So a declaration, a property and a value, background color yellow. As far as the browser is concerned, it has to go through from the HTML first, and it's going through every single element in the page. So it starts with the HTML element, and then the body, and then maybe there's a header, and that has an H1 inside of it, and also a logo. And it works down through that tree, and then it says, OK, there's a main area, and there's a footer, and it goes down through every single element. And then it looks at every single property, and there's something like 693 distinct property names in CSS. But that includes sort of duplicates, because we've got shorthands and longhands, so it's not quite that many. But it has to look at every single property in CSS, on every single element in the DOM, and find one value. We need one answer for every property on every element. So a button, a single specific button, needs one background color, one text color, one padding left, one margin inline end, and so on. We have to get all 600 some of the properties. So the way that we do that is first we have to find the relevant and valid properties, and that it's like we got to find the selectors that match, and then we got to make sure that the syntax is valid. And OK, then we get a list, and it's maybe got too many things. And so then we need some way to remove duplicates, get down to just 1 or 0, but then we haven't specified everything, because that would take us a while. So then we have to fill in any missing properties. And then finally, at the end of that, we can resolve relationships between them, which can be like, well, we have to do some layout to figure out what a percentage means, or if we're trying to resolve variables, we can swap them in there. So first, we have to discard any invalid values. So background color, SmashingConf, that's not a color, get rid of it. Then we have to remove conflicting values, remove red, yellow, green. We've just got powder blue. And then if something wasn't filled in, we were just setting background colors. We didn't specify a color. So we're going to have to go get that from somewhere. And that might be inheriting it or grabbing a missing value or an initial value. For color, it would inherit. So then we end up with these two properties and their final values, and then we can resolve them. We can say powder blue is actually RGB something, 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 and maybe we've inherited canvas text, which is one of the system colors, and then we resolve that to an RGB value as well. So we go through these 4 steps. This is the value resolution process in CSS, which you were maybe never, how many of you were taught the value resolution process in CSS before? This is not a common conference talk? You don't get the, okay. We call those steps filtering, cascading, defaulting, which includes inheritance. So we talk a lot about cascade and inheritance, and they're sort of 2 steps in here. But the cascade is sort of its own step, and inheritance is half of a step. And then resolving actually breaks out into, we get resolving, I don't know, there's like 6. But the last 3 are all sort of different steps of resolving. But let's talk about variables. That's what I said this talk was about. So we call them CSS variables often. We also call them custom properties. It's a mouthful, the full name, custom properties for cascading variables, module level 1. They're properties. They're just properties. They're properties like any other property, except that we get to make them up. And that changes how they work. So we have to think about them going through, instead of these steps of imperative language, where we just read through the code in order, we have to instead think like the browser thinks about a declarative language, resolving a bucket of properties to make sure that we have one value for every property. So first, we're going to, oh, I said that. We're going to follow the yeah, I said that. So we're going to skip filtering for now, but we can start by resolving conflicts. We get rid of red, yellow, and green because we have powder blue, and that one wins the conflict of my color, and we get one value out of the end of that. And then that's only happening. Code order of appearance is part of the cascade, so it's part of how we filter, but it's the last step of the cascade. So there's all these things happening before, but we have the same origin, the same importance, the same context. All of those others are the same, so we make it down to the end. Order makes the final decision. That's part of cascading, but it's not part of a series of steps. It's a part of cascading to resolve conflicts. And then, finally, when we're down to, we have one background color, it's set to my color, and my color is powder blue. We can fill in that, and we get the answer. The answer is powder blue. Some of you may have already been there when I asked the question, but it doesn't matter the order of the 2 properties in relation to each other. We can move those around any way we want. They still resolve exactly the same. Order only matters within a property because that property now has conflicts. That conflict has to be resolved by the cascade. The cascade gets to order of appearance at the end, and we get this answer. So we can get the same answer, but through a very different series of steps. Why am I talking about this now? There's a lot of new features coming to CSS. Container style queries are in most browsers and are being worked on in Firefox. Inline conditions with if are starting to ship. CSS at function rule, where we can define our own functions. That's starting to ship in a few browsers. Mix-ins are a little bit further behind, but the spec is coming along, and there's interest in shipping this. And all of these are sort of features inspired by features in imperative languages like SAS or other preprocessors or in JavaScript. We've already got variables in math and color manipulation and nesting, and now we're starting to get if and function and mix in. We're getting all these powerful features, but every time we make the jump from one of those preprocessing languages into CSS, it fundamentally changes how the feature works. And I think we need to learn that. So the value resolution process in CSS, filtering, cascading, defaulting, which includes inheritance, and then resolving. We need to, I don't care if CSS is a programming language. Doesn't matter. I don't care how you define programming. I do care if we're being dismissive of a language that we need to learn because we're using it. I think we need some understanding of. Sorry, I couldn't get a photo while you had that slide up, Christine, so I photoshopped in your slide. Anyway. So filtering finds the relevant declarations. And we've talked about a declaration is just like color blue, property and a value. There's technically 4 steps to that. It has to be in a style sheet that applies to the document. Sure. So mainly there we're looking at, is the link tag have a media attribute that's print and we're in a screen situation. So that CSS doesn't apply, we can get rid of it. And then it has to be not in a false conditional, which is a very similar sort of thing in a double negative. We look at all the at rules, at supports, at media, at container, and we say, well, if it's not inside one that's false, then this might be a relevant declaration. It has to be in a selector that matches the element. It seems fundamental. And then it has to be syntactically valid, and that's the one that we're going to dig into a little bit, because what is syntactically valid? Did you know that CSS is a strictly typed language? It has a lot of type safety built in. We've got types like integers and numbers and dimensions, lengths, calc sums, colors, and then like bits of colors, subtypes of the color type, hue, alpha value, image position, strings, URLs, all sorts of different types. And then every property in CSS, all of the predefined ones, the non-custom properties, have a built-in table that shows what types are allowed in that property. So the color property, and this will shock you, big reveal, color property accepts color values. Yeah. And anything else gets thrown away. So this is not valid syntax because CSS parses HTML color 3M, and it says 3M is not a valid color. We don't even need to check if it's a valid something else. We know that it's not a valid color, and we know that we only accept colors here. So we can just get rid of it. Teal, now that's a named color, and a named color is a type of color, so we can keep it. So if we set both of these side by side, and we know that usually the second one will win the cascade, but we're not at the cascade yet, we're still filtering. And we can just eliminate the one that doesn't match our type. And now we don't have a conflict. We don't even need to cascade. We already got our answer. We're going to get teal. Following? Great. So this is called parse time validation in CSS. So when we're filtering, we can do parse time validation where we check types, make sure that they match, and get rid of any that don't match. And this is really useful for progressive enhancement because we can say that the color is teal, and if you know what OKLCH is, use that instead. And so a browser, some browsers are going to look at that and say, OKLCH doesn't sound like a color I've ever heard of, and they'll eliminate it at parse time, and they'll fall back to teal. Other browsers are going to look at that and say, okay, both of these are colors, we're going to have to apply the cascade. And so then the cascade will come along, and it will do its thing, and we'll get the second one. And so this is a really handy way to be like, if you know what OKLCH is, use that. If you don't, here's your fallback. And there we lose teal. You can use it and not use it at the same time. It's quantum CSS. It's magic. I highly recommend a second call out to Jen Simmons today. Check out her Intro to Resilient CSS videos. All right, so what is the background color here? We're applying my color. We already know that cascade-wise, the order of background color and my color doesn't matter. But we do have to resolve a conflict with my color. But one of those values is not a color. Unless, is SmashingConf a color yet? We should see if we can get that in the spec. Custom properties don't have a type. In fact, just about anything is allowed in there. This is valid syntax. You can do this table flip. And I have a code pen where I figured out how to make it do something. It would flip the table. But it's valid syntax. So this is valid syntax, my property teal. We can set my property to teal. It's a color. Great. We can also set my property to 3M. That's not a color. Both are valid. And we can set the color property to use the variable my property. That's valid syntax. All of that is totally valid. And that means this is valid. We can set my property 3M, and then we can set color my property. And everything we've written is valid syntax. There's nothing wrong with this at parse time. Might fail later. So this is still valid, and this is why it has to be valid, because we could still get an actual color in my property that could become a color from somewhere else, and the Cascade would have to resolve that conflict and tell us whether we got a color or not. And until we know the result of the Cascade, we can't discard any of these. They're all valid. So at parse time, we don't have enough information, and we have to just keep it all around. We're waiting until we resolve before we can do anything about that. And we still have to get through filtering, cascading, and defaulting before we can start to resolve. So any declaration containing the var function is not evaluated at parse time. That's a universal truth in CSS. If you put the var function anywhere in a property, parse time validation just ignores it and says, well, it might work. We'll find out. So we have to wait until resolving, which we call computed value time. That's when we get computed value. And that's where, if you're using JavaScript and you do get computed value, it's waiting until we get that one, and then it's giving us the computed value at the end of resolving. So it might become invalid at computed value time. And that's a technical term that I think everybody needs to start learning, because it's going to become very important for all of these features. Not only do variables make a property invalid at computed value time behavior, they sort of opted into that, but also the if function will opt you into that, and any custom function will opt into that, because none of them can be evaluated at parse time. I'm just going to blow past this because you understand it. You can come back. My slides are online, and you can play with these demos to see that working in action. So all of this, even if we add a registration, and we might think, well, we just register my property, and we tell the browser that my property requires a color, then it should be able to do that parse time validation for us, right? That seems reasonable. And the answer is no. And the reason it won't is because we could do the same thing again. We could duplicate that property registration. We could register it as a length. That could come somewhere else in the CSS. So again, we would have to wait until we've parsed all the CSS and resolved all the conflicts between property registrations before we could be sure that it is a color. So still, we won't check that syntax. All right, so let's move on to cascading. So the Cascade handles declaration conflicts. It's like Tina Turner in the browser. 2 styles enter, 1 style leaves. And it's all these steps. Origins and importance, and then shadow context, and element attached styles, and cascade layers, which are fairly recent in the last 4 years. Selector specificity, and scope proximity, which is in Interop 2025, so we should have it by the end of the year, and then order of appearance. So there's all these steps, and we're sort of most familiar with these 3 at the end, or selector specificity and order of appearance, and then importance, which gets a lot of attention. We know that variables cascade, they're just properties. So what's our background now? If we have the background set to maroon, important, the background is also set to my color, not important. My color is set to deep pink, important. That's the best color in CSS. My color is also set to powder blue, not important. Does anybody know what color we're going to get? Maroon. Exactly. Because these two properties resolve separately in the cascade, and at that point, they're not related to each other. Once we've determined that maroon is important, the relationship with deep pink isn't important at all. We wouldn't even need importance on maroon if we just put it after background my color, right? So if we just make it, the variable is not applied, importance doesn't get passed along. So if a variable is important, that variable is important, and that's it. It doesn't make the place that we apply the variable important at all. So importance applies to custom properties, not the properties that we apply them to. If you want to go really deep in the Cascade, I have a workshop on Thursday. Come find out more there. Let's move on now to defaulting while I still have time. So defaulting is where we've now narrowed it down so that we either have 1 value or 0 values, but we might have 0, and if we have 0, we have to fill that in somehow. So we have to do some defaulting to fill in the empty values. Some properties inherit, but not all of them. Most properties don't inherit. I haven't been able to get an exact count of properties that inherit, but I think it's a significant minority. And generally, if you sort of have an instinct, if you sort of have an instinct about what does or doesn't inherit, your instinct is probably right. So here I have a span in the middle of that. I can do some zooming in. There's a span in the middle of that paragraph. And the idea of inherited properties is that when I put an element, like a span, inside of something else, nothing should change. And in order for that to happen, that span has to inherit, well, the color, so that the color doesn't change when we add the span. It has to inherit the font, so that the font doesn't change. It has to inherit the font size. So anything that you're like, would this change, would adding a span here, if we did inherit this, if we inherited padding, suddenly we would have all this space in the middle, and we can actually do it. So we can say all inherit. And there we go. So if we inherited padding and margin and all these box-related values, it would sort of blow up our layout every time we added a new element. But by only inheriting the text-related things by default, we get sort of what we would expect of things staying roughly where they were. So you can always just sort of imagine adding a span, and that will tell you whether something should inherit or not. Inheritance always happens directly from the parent element. So if we've got color set to red on HTML, we know that color inherits, and then inside of body, we have the main element. It's going to inherit the color red if we don't set something else. But it does that through the entire lineage. So the body inherits color red from HTML, even though we didn't say that specifically, and then main inherits color red from body. So inheritance requires this direct lineage. If we added in that the body is color blue, now we've lost that lineage to HTML, we inherit blue. If you want to find out more about building generational wealth, you too can become an evil oligarch. Custom properties inherit by default. So if we set, this is the standard way of using custom properties. Brand color pink, deep pink. It is the best color in CSS. We might as well always use it. Always use it as your brand color. This is now a design talk. We can just set those on the root element. I use the HTML selector. It works just as well as the :root selector. And then it will inherit and will be available everywhere, and we can use it wherever we want. Great, that works. The other great thing about custom properties is that until we use them, they don't do anything. They just like hang out, invisible. So we can sort of like smuggle context that we wouldn't be able to inherit directly in a normal property because we're changing the color, but we can like have this other color that's secret, and we pass it down the whole way from HTML to our button or something, and then we plug it back in. And we've inherited all the way from root, even though it wasn't that color in between. So if you can avoid inheritance, you can inherit across generations by doing this, which is a really useful way, I think, to use CSS variables, custom properties. So we can say, if we've got color red on the root, and then we're changing color on our section and on our div, you can see that our strong element in the middle is inheriting from the nearest one, because it's always going to. But if we add this root color, and then we might as well use it in root. We called it root color. And then we can also use that. Oh, we have it already there. And so we can inherit this thing all the way down to the root, from the root to our strong element, because we can sort of sidestep all these other changes and pass it the whole way along. Inheritance is, because we're in the defaulting stage and we already did cascading, defaulting is just filling in where we missed a value. So inheritance is, by its nature, a fallback. It's what do we do if we didn't say something explicit? So we've got all of these elements, and it's absurd to act like giving them dotted outlines in a layout is unstyled, but those are unstyled. We've got all these unstyled elements, and then the cascade applies specific values to some of them, but not all of them. We're not setting color on every single element on the page. We're setting color on some things, or border color, or whatever it is. And then the browser has to come in and fill in missing values, and that happens after the cascade has already applied. So in that sense, we could say that the cascade has priority over inheritance, right? Because it went first, and inheritance only happens if the cascade didn't have an opinion. So cascade will win conflicts between the two. That is some very small text, and I think it's because of this exact thing. So we've got a button inside of main, and I have set, and I've seen a lot of people run into this issue where they'll start adding importance to something, like on the HTML element. The font family should be fantasy, that's important. The font size should be 2 Ms, that's important. It should be much larger. The color should be red. All of that is important. But none of those things are actually going to inherit into a button by default, because the browser is applying some button styles. Computed. Well, let's actually go back to styles. Let's bump the size of that up. So here we go, button user agent styles, and we've got, we're showing a lot of properties there that aren't being set, but then here's some that are being set. Color, button text, all these things that are not going to inherit because they're set by the browser. We didn't set them, and so we think our importance should do something, but they were set in the cascade by the browser using a selector. So if we actually wanted them to apply inside of, oh, I can't just do it that way. Gotta get all of those. Right, so we could inherit these things explicitly, but they're not going to inherit somewhere that they've already been set by the cascade. And adding importance isn't going to affect that, because importance is just part of the cascade. It's not part of defaulting, so it has no impact. If a property doesn't inherit, like the border and the padding and the margins, I think of it as basically like font things inherit and box things don't inherit. It's not a perfect division, but if something doesn't inherit, then it needs to have an initial value. And every property has an initial value, even the ones that inherit. But that's what we're going to use if we're not inheriting and nothing was specified. Each property has an initial value defined in the properties definition table. And I might as well, you can find the you can find the initial values. Come on. Yeah, that's just the definition of it. I want this. So you can find them in the spec, but you can also find them in MDN. If you go to the formal definition section of any property, so we're on the color property, but in the formal definition, and then it says the initial value of the color property is canvas text. The real surprising one here is display. The initial value of display, formal definition, is inline. And that means on everything. So if you ever want, here's the ultimate reset. Here's the Smashing website. Let's open up those dev tools again. We'll add a selector here, select everything, set all the properties to initial, and let's just make that important. Works great. So not only is everything now inline and canvas text colored, but we can even see here in the head, we can see the head. We can see the title, that's there at the top of the page. We could zoom it. Whoop. Why did I lose my style switching over there? I'll do that again. Star, all, initial, important. Yeah, all right. We can see the head, we can see the title, we can see some inline CSS here, I think. Let's use this. Yeah, there's a script tag, there's a style tag. Every single element has an initial display value of inline. Everything is display inline by default. And that's why if you set something to display hidden, and then you set it back to display initial, but you're doing it on, I don't know, a button, you didn't want that button to become inline. Or you're doing it on a modal. You didn't want that modal to become inline. You wanted it to go back to being block like it was before. But that style is coming from the browser. So everything is display inline, background transparent, color canvas text, font style normal, flex basis auto, just down through the properties. Every property has its initial value, and that initial value applies to every element the same. The body is display initial is inline. Sections are inline, divs are inline, spans are inline, doesn't matter, everything. And then the browser comes along and gives us some, frankly, pretty necessary defaults that say, okay, look, some things should actually be hidden and some things should actually be block. We do actually need things to look different. So custom properties don't have a definition table where we can go look up the initial value. They get the guaranteed invalid value, which you can't ever request otherwise. There is no syntax for it. It's a lot like undefined in JavaScript, except that undefined is undefined. You can just write undefined, and you get it. And this one, you can get by asking for initial on a custom property that you haven't given a different initial value. But it's the only way you ever get a fallback. So if you're used to this var function with, it takes the variable name and then a fallback, you only get that fallback if the variable ends up being the guaranteed invalid value that you can't request. And so if you register a property, you won't ever get the fallback. So I don't have a registration in here. So not a color. So even if we get an invalid value there or an empty value, we're never falling back to green. We're not even falling back to orange because we're dealing with invalid at computed value time. So we've already gotten through the cascade. We've already decided that this second color property won the cascade. So we're going to get not a color or we're going to get green. We got not a color. It's not a color. So we go back to the initial value of canvas text, and that's the value that's applied here. And even if we registered a property, we would still get that behavior, except that with a property registration, we would get the initial value of our custom property that we set, but we would still never get that fallback. every time that we add a type to a property using the registration syntax, it also requires an initial value, and then we would fall back to that initial value instead of falling back to the fallback in the var function. We will never get the var function fallback if we have typed a variable. They're never guaranteed invalid. I'm arguing with the working group that we need a way to say, no, please make this guaranteed invalid, but we don't have it yet. Typed variables just never fall back. That's another demo of that. I'm going to keep going. So we also get these explicit defaulting global keywords: initial, inherit, unset, revert, and revert layer. Initial goes to that value from the spec. So don't set display initial on things. You probably also don't want to set display inherit unless you really are sure. Maybe what you want is display unset, and then that will pretend like you never set it. Maybe, but you also probably want what the browser set. So maybe you want display revert, or maybe even revert layer, because revert layer, if you didn't use any Cascade layers, will act like revert. So revert will give you, or revert layer will give you the previous layer. Revert will give you the previous origin, which is the user preference or the browser. Unset will just pretend like it was never set, and then that will either inherit or get the initial, depending on whether it's an inherited property. But if you're using initial and inherit, you should know what you're doing, because that's like, I know which one of these I want, otherwise use unset or one of the reverts. So we can apply these to custom properties, and I don't have time to get into the demos, but again, they apply to the custom property. They don't get passed on from the custom property. So we can't say initial custom property initial, and then pass that into color and get the initial value of color. We just get the guaranteed invalid value because that was the initial keyword was applied to the custom property, and we got the result of that initial value, and then that gets passed along. Use unset or initial to get the guaranteed invalid value on properties that aren't registered, and then you can get the fallback. This is how the space toggle hack works, if you have used that or want to look it up. So anyway, we finally get to resolving, and you could inspect in the dev tools. We could look up here. In the dev tools, we can find the computed values of things, and we can show all or not show all there to see all the properties if we want to. And we can see that we set the font size to 2M. The computed value of the font size is 32 pixels. And just to jump ahead, that is also the value that inherits here is 32 pixels. Because if we inherited 2Ms, we would then multiply it again. So we don't inherit that. We don't inherit the specified value. We inherit the computed value. And this makes a big difference, again, for variables, where we might do even complex calculations in a variable, and then we inherit the wrong thing. We expected to inherit the calculation, and instead we inherit the result of the calculation if it's typed. So this is a weird thing where defaulting has to happen before resolution, but also resolution has to happen before inheritance. So really we're going step by step through the DOM tree. The parent resolves, then the children inherit the resolved value from the parent, and we move on. Resolution depends on type. So colors become RGB, lengths become pixels, angles become degrees, but untyped custom properties, they don't have a type, they don't resolve, and so we inherit. We do substitute any variable references, and we inherit that, but we don't resolve the calculation, like 2Ms. If we put 2Ms in a custom property, by default, we will inherit 2Ms, not 32 pixels, because it doesn't know that it's a length to resolve. And so we can play with these, like registering a property means we can inherit the result of 2Ms, or the result of a calculation, but inheriting it without typing it means we get the... This is getting into the weeds a bit. Again, I'm just going to keep plowing through. The result of this one is red. On each element, for each property, we have to go through all these steps. Filtering gives us a list of 0 or more declared values. Cascading gets us down to 0 or 1 cascaded values. Then defaulting gets us exactly 1 specified value, and then we can start resolving to get 1 computed value. And then we move on from there to actually get a used value and an actual value, but we can't access those from JavaScript or anything. And we just repeat this down through the DOM as we go. Properties inherit the parent computed value. Var, if, and custom functions are all going to have this invalid at computed value time behavior that you need to start understanding, or it's going to trip you up. And fallbacks are only useful when we have the guaranteed invalid value. So, I mean, I have some demos here that are functions, and I'm not going to play with them too much, but we can define a function, and we can actually tell it what types all these properties are. We can do all sorts of typing along the way in those functions. This one here, I just wanted to show that I also built a conversational interface just like ChatGPT. So right now the prompt is the silty sediment that swirls at the bottom of a riverbed, et cetera, et cetera. I thought it was too easy to just like say what color you want. So instead you have to describe the color, and you have to describe it exactly. We're just going to change that out, and we're going to instead get the color of Vitaly's freshly ironed shirt as he tells jokes on stage in New York. I took a photo. I did the little dropper, so I can tell you that that is the color of the shirt. If you thought CSS was programming, it still is, but with more features. If you thought CSS was not programming, it's still not, but with more features. So either way, you're happy. If you just want to code some styles good, I have a course that I'm working on, and you can sign up for updates. Thank you.
Thank you so much, Miriam. So please join me for a little conversation. Wow, this is so much stuff that's happening. I mean, in the beginning, I remember maybe 10 or 15 years ago, people were saying, oh, CSS is easy. People who are writing CSS, doesn't matter. But wow, we're getting to the point where it's really, 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 really advanced. I think one question that came up immediately, really immediately, was where does this new innovation in CSS leave Sass?
Yeah. I think the distinction is going to become more clear. I think of it as similar to Node and JavaScript in the browser. Mm-hmm. Like, if you don't have to solve a problem in the browser, don't make the browser do it. Put it in Sass or something like that, where you can solve the problem on the server before the browser has to worry about it. If it needs to be dynamic in the browser, put it in the browser. It's good to have tools in both places. So for me, that's often like design systems. A lot of design system logic can happen in Sass. I have all sorts of tokens that are useful to me but are not useful to the browser. Mm-hmm. And I'll use those to generate the tokens that are useful to the browser.
Makes sense. OK. Well, it didn't take long. Tailwind.
I don't know.
Namely, yeah.
Namely, like you.
If you think about inheritance, right? So I think like the question that some people have. So Tailwind, what are some good and best practices? That's a question. But also some people want to achieve some sort of scoping to avoid repetitive classes in HTML. Others are allergic to using @apply or CVA, which is this class variance authority that introduced. What's your overall take on this?
My overall take is that they are reinventing the language at every step, and then they cause problems that make it not possible to use a new feature that gets added in CSS, and then they figure out a way to solve that problem, adding the same feature we already added, but with a new syntax. And to me, that's not helpful. And to me, particularly, I get a lot of questions that are like, well, how do I use layers in, I mean, I think they've added that maybe now. But how do I use this new feature in Tailwind? And the answer is, well, I don't know. I guess you wait for them, because now you have this third party that gets to decide what features are available to you and what features aren't. And to me, that's the barrier of when a tool becomes an obstacle. Like, I will not use a tool that doesn't just let me use the language, because it's always going to, at some point, be in the way. Mm. But also, like, I don't know, if it works for you at work, do your work and go home and make art. Like, it's fine.
Okay. So this is an interesting question. Why do we actually still need to normalize CSS styles across browsers? Is it really still necessary?
I don't think it's particularly necessary. It depends what you want. I think most resets these days are actually more about like what are the styles that I like as a default and just sort of providing your own default. And so if that's useful to you, that's great. I think there are very few styles at this point that differ between browsers, and a lot of them are really obscure. Like if you look up the really complicated resets, you're not using 3/4 of that shit. And just like don't bother. So my reset is like 4 lines of code now, and it's not really normalizing across browsers. It's just, I don't know,
Just
some defaults I like.
better defaults.
Yeah.
Makes sense, makes sense. Victor is wondering, how can you incorporate accessibility into CSS architecture? Like making sure a high contrast mode or dark mode works cleanly. Can we use inheritance to help with that somehow?
Yeah, well, some of these new tools are going to help with that quite a bit. And I didn't really talk about the color functions. I think they're some of the coolest stuff in CSS right now. But like the light dark function is super useful for being able to respond to user
The switch
preferences.
between the modes, right?
Exactly. And once you start getting if and style queries, those two things combine really well, and you can start. So the light dark function only works with colors, so you can only switch colors. But say in dark mode, you actually want a little bit of spacing in your text, and you've got other preferences that are interacting with that. Being able to sort of wrap that up into a function or do some like, well, if the scheme is this and we're zoomed in, then but yeah, I don't know. I mean, I think all of these features help us. What I'm going to talk about a lot at the workshop is that the Cascade is mostly for solving that problem of how do we and the browser and the user somehow all design a website together and make it work. And how do we make sure that in that process, the user gets as much control as possible? The Cascade exists. Holcomb Lee called it a cascade of style sheets because he was allowing authors and users and browsers to apply style sheets. And that means we could have any number of style sheets. And somehow we're going to have to resolve conflicts between them. And the whole thing exists so that before CSS came along, only browsers and users applied styles. And they did it through just user preference, choosing your browser and then setting your user preference. And that's all the styles across the entire web. And then all those styles apply to every website consistently. And it's great because you have full control. It's fully accessible. Yep. We're the baddies. We don't get to come in and stomp all over your preferences. But it's also kind of boring. So nobody was really happy with that, but also if you allow us to come in, then we can override the user, and that's a problem. So then importance actually exists so that the user can override us. It's not for us. We just sort of like use it and get in the way of ourselves, but it's for the users to override us. And so there's all these features in the Cascade that exist because the web is for somebody else, right? And that somebody else is us the rest of the day. But the web is supposed to be user-controlled. And so all of cascading and inheritance exists to solve that problem of accessibility to some extent. And a lot of the things that trip us up are there to solve accessibility problems. And if we get in the mindset of thinking about them as like, no, that's a feature, it's just a feature designed for somebody else, and I shouldn't get in the way of it, we can get less offended by our lack of control on the web.
Yeah, but also I think that it's interesting what you're saying here, because I think very often it seems like we are creating almost traps for ourselves as we're writing CSS. And I'm wondering, given just the sheer amount of CSS features we have, we can do like so many really incredible things. What do you think is, or what do you think are kind of the most common things that we often get wrong when when we're using CSS, building CSS architecture or just writing CSS?
Over constraining is the way that I would think about the main problem that we cause. Is we're trying to get something exact, and we have the idea in our mind of the exact thing that we want, and we add a lot of properties until we can force it. And the web and CSS particularly are not designed for that. They're designed for us to try and communicate to the browser an idea of how things should move, and how, when one thing fails, how something else can pick up, and how we never want to lose the content. And so that's why like overflow is visible by default. Not because it looks good. Nobody cares if it looks good. It makes sure that we don't lose the content. And a lot of CSS is designed around that, where if we really say exactly what we mean, then the browser can be smart about like breaking it cleverly.
Mm-hmm.
But if we get too intent on enforcing our vision, then the browser doesn't have room to solve the problem and incorporate the user's preferences and all these other things.
Right. And maybe also kind of going even further there, there is a question that came. We are working on a product with years of legacy CSS. If you were tasked with modernizing something like that, what would be the very first important step that we should take? And where do we even start, given just the incredible amount of CSS features we have?
Yeah, I would have to look at the code base. I mean, sometimes I look at a code base and think, oh, actually, we could just delete this and get what we need in an afternoon. That's not always going to be true.
Sure.
And across a large enough platform, that's not going to be something you want to try. But in some code bases, that's totally reasonable. See if you can rebuild it in an afternoon simpler. Because a lot of legacy CSS does just tend to stick around in code bases and without even being applied. But no, the main thing that I would start with is if you start adding in layers, then you have a lot of control over what overrides what. And layers, by default, deprioritize things. So I sort of start at the bottom. I start with a reset. If there's a reset, I put it in a layer. And then if there's third-party tools, I start to put them in layers. And I just sort of work from what I think of as the bottom of my code, which is probably the start, the stuff at the beginning, the stuff that's global. I start layering that. And then once everything is layered, I have a lot of control to just move layers around. Or like, what happens if I pull this layer out? What happens if I rewrite the stuff in here? That's probably where I would start.
So I do have to ask, I'm just curious, do you ever, like if you're writing like CSS today, do you ever have a situation where you feel like, I need important here?
Yeah, so the way I would think about it, welcome to my workshop, is importance is designed for users to protect their styles from code that's going to come along later. So it's not about overriding something that was there previously. It's about protecting something important from future styles that are usually higher priority.
So maybe then third-party styles.
Potentially, that's a bit risky. But yeah, my reset is sort of like I have the hidden attribute. The hidden attribute is if we set section display block or display grid or something, and then we put the hidden attribute on it, it won't disappear by default. Because the hidden attribute just applies some CSS in a presentational hints layer before us. And so we just override it with display grid or whatever, and hidden doesn't do anything anymore. So that's broken. Hidden is something that is a reset. It makes sense for it to be sort of in that global, low priority, low specificity. That makes sense. But also, it's something that we want to protect. We want to say, when this is there, it should definitely apply.
Right.
Nothing should come along later and override it. So that's the one place where I have importance in my reset.
Okay.
because when the hidden attribute is on something, it should be hidden. It should just be hidden.
Right. Maybe there's the final question because we're also running behind the time. Do you have some? It seems like we've done so much. I mean, not me. You've done, and everybody else of us who contributed, done so much in CSS. Is there something that you still have on your wish list?
Well, a few of these features don't exist yet, so they're on my wish list. Well, so I've been following the grid masonry layout discussions closely, not because I'm particularly interested in masonry as a layout, but because I think they're solving a lot of problems about how do we add new layouts, and that I'm interested in, because there's one I really want, which is, like, if you think of masonry as being grid on one axis and flexbox on the other, sort of, I want grid on one axis and normal flow on the other. Normal flow is the default layout model, because I want to be able to write articles, but like push things. I want to float things into a grid, right? And I think we can make that happen. I think we can make floats
next
into
October.
grid.
Next
Yeah,
October.
next smashing.
Yeah, maybe that would be fantastic. Well, thank you so much, Miriam, for being with us.
Yeah.
And of course, if you have questions for Miriam, please do come and ask. Thank you so much for being with us.
Thank you.
Fantastic, thank you.
Yeah.